Alright, let's say you've got a water pump that's not working. Sometimes they can get blocked up. Of course, this will be where your water pipe's going in. You might have a bit of muck that's gone in there, and then that blocks the top of this. This one's got a wee bit of stuff, but this isn't mucky. Look, I'm talking like, like seaweedy type stuff, and shit that comes in and blocks all that. But if you've got a filter like I have in the tank, you sort of don't have to worry about that too much. But I still do get a wee bit of silty stuff, which you got to watch for that too. Make sure you get as much of the crap out as you can. And there's a couple little bits of cruddy stuff inside there, so we'll clean these out anyway while it's all apart. You just see there's just a bit of build up from like silt build up inside it, but there's no cracks, no loss of pressure anywhere. There's a bit of crap just there too. Of course, check these out as well, especially for your frosts. What can actually happen if you don't protect these in the frosts? These little things here, basically your diaphragm, when you've got a bearing on the back of this, and that's in your motor, it's offset. See, it's not central, so as it's spinning round, it's going around like a buckled wheel, but of course it'll be centered, so it can't go around like a buckled wheel. So what it does, it pushes each diaphragm out like that, each little thing, and that's how you get pressure. So of course you make sure these haven't got any cracks in them. I have had that happen before in frost. I actually put a cover over mine these days, make sure that doesn't happen. It's a good idea to cover your pumps if they're out in the frost, or keep them underneath the house or the building, or the structure, whatever they're giving water supply to. Of course, the other thing you want to check. Alright, so once you've done all that checking on that, you know it's okay. You want to check that bearing. As you can see, it's pretty brand new. This pump's actually only 6 months old. But I've got a problem with it. It's not turning on all the time when I'm turning it on. But there's no problem there with the bearing. Bearing's fine. That is one of your standard bearings too. You can only see the number of the bearings there. Pick up a new one. But that one's all good. I might just put a little tiny bit of grease in it, just to give it a bit more extra oomph. And of course down here too, if you do end up having to repair any, when you're screwing those screws back into your plastic lugs here, make sure you don't overdo it, and make sure you're putting the right sort of screw in. You don't want to crack them. If they've got brittle in any way, you will crack them, which is, done that in the past as well. Anyway, so once all those things are done, you're sweet. At the top here, of course, this is for your pressure, and you got your thermal. You got pressure overload and everything here. These are your adjustments. Normally you only have one on a lot of pumps, which is normally this here, which is just your pressure cut off. So auto cut off when you turn taps or anything off. The only problem I've found with them, sometimes they can go faulty, but there was a different brand of pump than this one. This one hasn't gone faulty yet, but I don't actually use that in my system. I actually have on-off switches in the taps, or on-off switches that you actually flick on and off, so that way you don't rely solely on this. I had at one time where I relied solely on that. Different brand of pump, as I say. It was one where it just has that in the middle. You don't have this other cutout pressure thing here as well. Actually, that might be the thermal cutout. Or it's another pressure. No, it's another pressure one. But anyway, yeah, in the last pump it didn't cut off, and I actually came back, and then my pump was actually inside back then. It's outside now, and but yeah, of course, being left, that didn't cut out. It was back when I didn't have switches on taps, and I relied on that cutout, pressure cutout, and what happened is it never actually cut out. So the pump was actually running even though it couldn't spin. So I arrived back to a pump underneath my sink that was so hot you couldn't even touch it. I mean, you could have roasted a steak on it. And all the wiring was getting melted, and yeah, there was a whole heap of disasters going on. A bit of shit's gone into the pump at some stage. It's not actually a crack, just a wee chip. Right, and of course this is your pump. That'll be on the end here. And of course this is the end where your brushes go. You'll see there's a bit of buildy shit, stuff all over that. I normally clean them up a bit. Just get a real bit of real fine sandpaper. and just clean them up. And those grooves, you can clean them up a little bit with a really fine screwdriver or craft knife blade. Don't want to go overboard. But check all these here, these little wires here, make sure none of them are broken off. You have having troubles. But I did notice this brand of pump actually has, what is that? So I'm presuming this must be some kind of thermal cutout. It's either that, well, yeah, I mean, it has to be, might be, yeah, but I think that this is actually faulty, because I've done a check out through the whole system. You'll see here the brushes, and of course there's plenty still on the brushes. If I was to push them back, I mean, that motor's way back here, so these brushes have still got heaps of wear left on them. So it's not actually the brushes, but of course other brands of pumps I've used in the past don't have this inside next to the brushes. So I'm just taking that out. I believe this is actually where the fault is, whatever this little thing, so it could be a thermal cutout or something's gone faulty. So what you do is just wire it straight up. This did used to be here on your positive, from there over to your brushes. But of course, yeah, I've just bypassed it. So we're going to see if this pump will work again now. What else you got to do? Basically, yep, give that a go. Hopefully it fixes your problem. I mean, do remember, like, I mean, I'm doing this because of course, as I've got switches on all my pumps, all my water supplies everywhere, so I'm actually turning on and off. So if I wanted, I could take out them too. But just bear in mind, if you haven't got that stuff, once you start doing certain things, it's not going to shut off and do certain things. But this is the way of getting your pump going again. And of course, this pump, I've actually got this fused on a separate line as well. Well, this pump can actually take up to 15 amps. It's only a 6 amp pump, so I actually run a 10 amp fuse on it. So that way, if you do have any overheating problems and that, your fuse is going to melt out anyway. So I think that's the best way to sort of run it. So I'll get this back together and I'll show you it running. Oh, just quickly as well, what you're better off doing. Now the other thing you want to be doing is making sure on the spindle here, this is where your brushes will be contacting. What you're going to do is get yourself a craft knife blade and go in these grooves. See, just clean the crud out of them. Alright, the other thing you want to do, just get a bit of fine emery paper, just clean that up a bit. And the next thing you want to be doing, see these brushes here. So they've got that shiny as glaze on the front of them here. So what you want to do is get some sandpaper and sand that off. See, it's slippery like ice. And it's got a glaze of shit on it. So it's not just smooth, it's just, yeah. And also you see the curvature. So what you can do is get a bit of sandpaper and just sand that flat. Notice the curve in that one. So I would say stupid bloody camera. if I was to up all the way again. Alright, so on another note, what you should do too with these motors, if you can, is actually take this end off, and that whole motor actually comes out. But of course, try and take that off the shaft if you can, and then feed the brushes and that onto this end first. Then put that cap on. But with some pumps, they crimp. You'll see there, they've crimped all that bent, so that way the bearing won't come out easily. So you've got to try and get it off the shaft. And what you have to do is get a file. You'll see there, there's a raft part in there that's stopping it coming off the bearing. And right where they cut this groove here, right at the tip of, at the end here, it's got a burr, so you can't actually pull it off. So you need to sand that off a wee bit, and you better get it off. Now if you can't, the other option you can do, which is what I'm doing with this pump here, first pump I've had to do it to for ages, where the brushes are, just drill yourself a little hole, just there, and just there. And what you're going to end up doing is, once you push your brushes in, which I'll show you in a minute, you're going to put a bit of wire in there, and that's going to hold the brushes out of the way while you push it on. Alright, so what you should end up having, let's say, after you drilled those holes, and I've just used the old bread tie, just, you know, cut off a bit of the plastic off of it, so you got the wire in there. And of course, we'll bend that piece, of course, bend that bit there, way slightly. It's going to be fine. And just make sure you've got a couple bits on the overhang, so when you put it together you can pull them out. So this is the way of doing it. As I say, if you can't get that cap off and you can't put this on first, but make sure you try to put this on first. It's another thing to bear in mind too when you're pulling them apart. This one here I actually had to pull apart back to front realistically. I mean, that part there should be coming off, and you should be taking the whole unit out the other end with this on. But as I say, if they're in a part like that, and you've got to do it this way, this one has to come off first. So when you're doing it that way, just be very careful when you are pulling these off. So maybe your brushes are going to be wedged inside here. You've got a couple of things there they can catch on. So yeah, bear in mind of that too when you're pulling them out. Just be careful not to break them. Right, so that's how you get around holding your brushes back. As I said, drill a wee hole. I mean, that's probably about a, what have we got there? It's probably about a mil, 1.5mm drill. Smaller the better. So just use a 1 mil if you can. Of course, you can use that trick for brushes and other motors you pull apart. Just make a couple little holes there. Initially, with the bigger the motor, the bigger the wire you're going to need. That wire wouldn't hold the pressure of brushes under a bigger spring, but these ones here are alright. So the old bread tie will just hold that back. So we'll put this back together now, and then I'll show you the last bit, just pulling those out. And then the next part will be showing you it running now that we've bypassed that cutout that it had in there. And another quick thing too, if you do have a pump and all that's broken or something, you still got a good motor, you can actually transfer into something that's going to create energy, create power. Yeah, of course, you get the drift. If you had another motor on that, yeah, of course you can get one that actually draws less amps again, still spin pretty much the same. You could use the less amp one to power that one, and the leftover amps you could recycle it through a coil, amplify it or put it through a capacitor, and then get some more power back out of it. So another thing you can do with them. Alrighty, now she connects back up, and you'll see she's away. Of course, there's the fuse. This one here, because this can be 6 amp to max of 15 amp, 5 amp fuse kept melting, so I put a 10 amp and it's not so bad. but I've got a 20 in there at the moment. 15, sorry, 20. But you'll get some pumps that are only a 3 amp pump or a 6 amp pump, and when you're getting ones like that, if it's a 6 amp, put a 10 amp fuse or a 5 amp, just depending. I mean, put a 5 amp in. If you find that it keeps melting, put the 10 amp in. You don't want it melting before the fuse, you want the fuse to be popping, you know. So that's what you want to do to making sure it's getting done anyway. So there you go, so there's the pumps all up and running.